Okay, common angle. So these two are the same already, right? So since 3 pairs of corresponding angles are equal, then triangle ABC is similar to triangle ACN. Okay, that is for part A. Since they are similar triangles, the sides, corresponding sides, they have the same ratio. So I like to write my unknown value in the top left because I'm going to be expecting a fraction equals to another fraction. Okay, yeah, we're going to have a fraction equal to another fraction. I like to put my unknown in the top left hand corner. It's just my habit. Okay, I want to find AC. So AC over here. Now AC is found over here as well as here, right? So I can choose to start with my big triangle or my small triangle because it's found on both sides. Okay, so if I choose to have my big triangle in my numerator, AC, so what goes in my denominator? What is the corresponding side to AC? What is the corresponding side to AC over here? AN, okay, AN. Yes, because I already said I want to put my larger triangle in the numerator. Well, if you chose to write AC over AB, still perfectly correct as long as your second fraction is still of the same format, the small triangle over the big triangle, okay? So next, AC over AN must be equals to AB over AC. How many unknowns are there over here? What is the unknown? AC. Okay, so can we fill up the blanks already? Okay, so AC over 4 equals to AB is 4 plus 5 over AC. You will get AC equals to 6. Do we need right? Okay, so let me just complete the steps for you. So you would have AC square equals to 36. So when you introduce the square root yourself, AC equals to, you are introducing the square root, right? You are supposed to put a plus minus. Okay, by right, you are supposed to have 6 or negative 6, then obviously you reject this, right? Now, because this is a question that is very clearly asking you for the length, in this type of questions, you are allowed to simply remove this negative over here. Then you get only one answer. Okay, but for completeness, you can put a plus, minus, or negative 6, then you reject it. Understand what I'm saying? Yes. Any questions? No. Okay, congratulations. This is actually an O-level question. Okay? Yeah, 3 marks. Quite manageable, right? What? Because you are just learning it only. You are just introduced to this type of question. Okay, so don't worry about it. Now we'll go on to 4.3 already. There's a class activity that I want you to do. Please turn to your textbook for class activity 7. We have as the ratio of base 10 to 20, which is actually 1:2, right? Right? Quite simple, right? Okay, how about now? I want to talk about the ratio of height. Okay, what is the ratio of height now? 8:16, which is actually 1:2. Do you realize they are the same? Yes. So you see, under my examples for sides, I've got all these things, including the height also, the length, all these things. As long as the triangles, as long as the diagrams are similar, we will find that they have the same ratio for side. Whether it is, if you want, you can find the perimeter also. Small perimeter divided by the big perimeter, you see that it's still 1:2. Okay? So now next, ratio of area. Let's try to find out the ratio of area. Small triangle, how much is that? 40. How do you get 40? Okay, half times 8 times 10 is to half times 16, 2, and 20, right? So what do we have over here? Simplify it. 1:4. Do you think there's a relationship between ratio of bases and ratio of area?
Yes.
Square. So, wow, you can tell based on one example.
No. We did this before somewhere. I forgot. No, not like that, but like I experienced before.
Oh, you experienced before. Okay, never mind. Let's try to explore a little bit more first. What about squares over here? Ratio of sides. Come, this one should be easy. 12 is to 18, which gives us 2 is to 3, right? Okay, ratio of area. How much is that? Ratio of area? 12 square is to 18 square. Simplify it, we get. What do we have?
4 over 9.
4 is to 9. This is ratio lah, okay? Okay, let's try with the rectangle. Ratio of breadth. 9 to 12. Simplify 3 to 4. Ratio of area. 9 times 15 to 12 times 20. 9 is to? You sure 12? 16. I hope you're actually working it out.
So,
Yes.
shorter side, right?
Yeah, breadth is the shorter side. But in this case, can I just, for the fun of it, right, ratio of length. What is the ratio of length?
What do we say?
15 to 20, right? Oh, 3 is to 4 again. Yeah. Wait, are you surprised?
No.
Why not?
Scale.
Yeah, scale drawings. They are similar, right? Okay. Yeah, Next one, circle. Ratio of the radius. So here we have 15 to 18. Simplify to become 5 to 6. So ratio of area. Okay, how do we calculate ratio of the, of the area? Pi 15 square to pi 18 square. So we get 25 to 36. Am I right? Am I going too fast? No, I think you are actually faster than me. I'm slowing you down. Okay, next thing. I want you to see the relationship between ratio of bases, ratio of side, ratio of breadth. Basically, on the left-hand side, all ratio of sides. Versus the ratio of area. What do you notice?
Square.
They are square. Right? Is that surprising to you? Why would it be a square? Why must it be a square? Itself times something? I think some of you have the idea, but are you very convinced that it is always going to be a square? No, not very convinced. Why not?
Because example is like trapezium, right? Or like a very irregular shape, right?
Okay.
Then you get two values. Then you want to find the area. Then the area may not fit the side.
Try again.
Not all shapes may work the same method.
Not all shapes may work. Okay, for example, this one octagon. I never give you the length. I give you A and B only. Based on our observations just now, right? We will want to say that the ratio of area is A squared to B squared. But are you convinced?
No.
Okay, let me try and convince you now. Hey, what's with the reaction? Okay, come. Ratio of area. Now, I don't really like to leave my workings in ratios. I prefer to work with fractions. Okay, so let's have the breadth, the base of the smaller triangle over the base of the bigger one. That is 1 over 2, right? And we got 1 over 2 because it was 10 over 20. 20, and we get 1 over 2, right? That was for this triangle over here. Okay, so now if I want the ratio of the area, I'll write it in the same format. Okay, area small over area big. Okay, so half times the base. Smaller triangle base was 10. Refer to your work. What is the height for the smaller triangle? 8. Okay, divided by half times 20 and 16. Okay, now I'm going to try and cancel. We're going to try and simplify. Half and half obviously cancel, right? Then 10 and 20. Remember this one was our ratio of, what was this? Our ratio of?
Base.
Ratio of base, right? So we can simplify this to become 1 over 2. That's the ratio of base. over here. Then what is this actually? Ratio of
Height.
height. Ratio of height. What did we say was the ratio of height?
1:2.
Oh, 1:2. Why is it that the ratio of base and the ratio of height is the same?
Because we
Because they are similar figures, right? So naturally I will expect 1 and 2 here as well, right? All agree so far? And is it a coincidence that this is half and this is half? No, it's because they are similar figures, right? Now, what happens when I have half times half?
1/4.
Hey, okay. Yes, I know the value is 1/4, but this is actually half square, isn't it? Then you get 1/4, right? See, it's a half square. Where did the half come from? From the ratio of side. Whether it is the yellow or the green color one, it's the ratio of side. And what did we do to the ratio of side to get a ratio of area? It times itself. In other words, we square it. So when I square the ratio of side, I will get a ratio of area. Are you convinced for the triangle now?
Yes.
Can we do that for the square?
Yes.
Okay, so I'll use the same example, the same format for ratio of area and the ratio of the side. Okay, so now I'll make it more generic. This will be side and side. So for the square, we've got 12 and 18. So 12 over 18. This is simplified to become 2/3, right? Yes?
Yes.
Okay, now area, small one, will be 12 times 12 over 18 times 18. Can simplify, right? Okay, 2/3 times 2/3. Isn't this the same thing again? Ratio of the side and I square it. Can see it already? Okay, now I want you to try something else, which is that for the circle. Try for the circle. Rectangle, very easy lah. So try for the circle and convince yourself that there actually is such a relationship. So pi can be cancelled. I'm left with 15 times 15 over 18 times 18. I'm just writing it this way so that you can see where the square of the sides comes out. So I got 5/6 times 5/6, which is actually 5/6 square. Okay, which is then 25/36. Okay? Now, so by now you should be convinced that regardless of the shape, as long as they are similar figures, we will have this relationship. So let us try some questions.
Who created this law?
Nobody created this law. It is discovered as you have discovered it yourself. Yes, Kevin? Find the area of ABC, which is the big triangle. Information given to you is that area of small triangle is 84. So this is 84 square centimeters. Then how to find the big area? Okay, you want to use ratio, right? Presentation. Everybody knows how to find the answer, but presentation, I'm going to have a lot of different presentations from you. Some I will accept, some I will not accept. So this is my recommendation. We are not going to work with ratio. I'll work with proportion. So area ABC. That is what I want to find out. I always put it in the top left. I'll show you why. Area ABC is what I want to find. Divided by area ADE. Okay, this is supposed to be equal to the square of the ratio of sides, isn't it? Oh wait, did we already find that? It is actually 4/9. No, ABC is the big one, so 9/4. Agree so far? Then now I will do the substitution. So area ABC equals to 9/4 times area ADE, right? 84. And I get the answer. So this is the beauty of putting your unknown in the top left. Okay, I get my answer very quickly. What happened? Okay, 189. Thank you. 189 square centimeters. What happens if I don't know, I randomly choose for example, I put area of ADE over area of ABC. What is this ratio now? 4/9. Okay, so if you want to do the substitution, you're going to end up with area ADE being 84 over here, right? So when you want to find the answer, area A, B, C. You may need to do a few more steps before you get the same answer of 189. Understand what I'm saying? Because now the unknown is in the denominator. Okay? So this is just a little trick for you to save a little bit of time, save a few steps, minimize your careless mistakes. Alright? Any questions?
So is ratio the same as fraction?
No. Ratios can be expressed in an equivalent form, which is fractions lah. Okay, so different presentation. I prefer to work with fractions because I can use everything that I've learned about fractions that can be done. Plus, minus, times, divide, cancel, all this kind of stuff. Whereas with ratio, it gets a little troublesome. Okay? Now, part C. Find the area of BCED. Where is BCED? BCED. Okay, how to find this area?
9 minus 4.
Huh? What?
The ratio ma.
9 minus 4. So are you saying that the area is 5?
So the ratio.
Oh, 5 units, whatever the units is, right?
Yeah.
So how do we find the value then? Big triangle minus small triangle, as simple as that. 189 minus 84. Okay? That's it lah. Then
What's the reason for all this?
there's no need for any reason. This is just mathematics calculation only.
Oh, this is right.
The reasoning that you have to write comes in part A. Okay? Now, I've got another question to add on. Please add on part D. Find ratio of A, D, E to B, C, E, D. Okay, what is the ratio? For the video, 4:5. Right, yes? For these two to be the same? I give you something to help you remember. Okay, here I've got parallel lines. In this one, A and B. What is the relationship between angle A and B? Relationship. Same. Okay, equal to angle B. What is the reason? Corresponding angles. Parallel lines. Okay, what about this one? A and B. What is the relationship between A and B?
A plus B.
Okay. A plus B equals 180 degrees. What is the reason? Interior angles, parallel lines. And the last one, A and B over here. Alternate angles, parallel lines. Okay. So what letters do you see? F, U, Z. Okay, yeah, these are the ones that can help you remember lah. What adjacent? You mean adjacent angles on a straight line? Angle A plus angle B equals to 180 degrees. Adjacent angles on a straight line. Okay, I don't want to go more into this already. All this should have been very familiar with you. Right, next one I want to go through. Let's take a look at this triangle over here. This humongous triangle that I drew. What is the base of this triangle? AB. Why?
Can be anything, any.
Can be any, right? Okay. If I choose AB as my base, okay, base.
AC will be hypotenuse.
Hypotenuse is only for a right angle triangle. Okay, so this is base number 1. Where is my height?
B go up all the way to C.
B go up to C, like that.
No,
Perpendicular, like that.
Yes.
Then where?
No, can't you see like that?
Yo. Okay, listen. If the base is AB, chicken, the height must start from there, where? You want to come and point? Or you want to say the letter? If the base is AB, the height must start from Hello, you only have 3 options, A, B, or C. Which one? Okay, class, where is the height starting from? C. Okay, my A and B already used for the base. The height will start from the one that was not used, start from C. What direction do I go? Down. I will have to extend this, right? So this is my height 1. 10. So some of you say that, hey, actually there are more than one possible base. For example, if this is my base number 2. Where is my height number 2? It must start from A. Okay, I need to extend it over here. So I draw from A perpendicularly down. This is my height number 2. Is there another base with height? Okay, where is it? AC. So this is my third base number 3. And where is my height? Must start from B, which was not used. So drop it down. This is my height number 3. All familiar with this? Okay, good. Now I've got 2 triangles. These 2 triangles, do they look similar to you?
No.
Just by looking, do they look similar? No, right? The angles look quite different. Okay? But there is actually a relationship between their areas. Before we talk about the areas, is there something else that is similar for these 2 triangles? Height is the same, right? Let's talk about the ratio, or rather the these 2 areas, okay? Area of ABC, how much is this? Area of ABC? Half times, what is the base? BC times H. Okay, what about for the smaller triangle? Half times YZ times H. So when you see this, are you happy? Why? Cancel half and half, H and H. Oh, we realize there is a relationship between area of ABC and area of XYZ. It is actually BC over YZ. Right? Am I right? Okay, so in summary, you see these 2 triangles, they have the same height. It tells you that the ratio of area will be the ratio of base. Okay? Ratio of area equals to ratio of base for triangles with same height. And that is found over here. Okay? For areas ratio of areas of triangles. First, are triangles similar? You have two options, yes and no. Okay, so if they are similar, ratio area 1 over area 2 equals to side 1 over side 2 ni squared. Alright? That's for similar triangles. Similarly for similar shapes. What if they are not similar?
Same height or not same height?
Okay, so we ask, do triangles have common height? So we have yes and no. So if they are the same height, area 1 over area 2 equals to? Equals to? Not side 1, side 2. Something more specific. What kind of side are we talking about? Base. So base 1 over base 2. Need to square?
No.
No need, So you must follow the flow chart, okay? So if they don't have a common height, then how? Good idea. Do they have common base? Why are we talking about common base? Let's draw triangles with common base. So for example, this triangle over here and maybe this triangle. Okay, so A, B, C, and D. Alright. Now, what is the height for ABC? This, right? So this is H1. What about the height for the slanted triangle? from D down, right? So this is H2. These two heights are different, correct? What if I want the ratio of the area? Area ABC over area BDC equals to half times BC times H1 divided by half times BC times H2. Am I right? They can cancel again. Cancel, 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 cancel. Because they have the same base. So the answer will be H1 over H2. Okay? So it is just a variation of do they have the common height. So let's continue with our flow chart. Do they have a common base? Answer yes or no. So if it is yes, area 1 over area 2 equals to H height 1 divided by height 2. So what happens if they don't have the same base also?
Cannot do.
Wait. It's not that they are not just that they are not similar. Because for common, look, I came to this part on common height because they were not similar to begin with. Okay? So in this chain, they are all already not similar. So when they do not have a common base, try other methods.
Did we learn the other methods yet?
No, it will be something that requires you to think and solve the problem on the spot. Okay, but it will be something that is doable. But basically, when you have questions on areas, ratio area of triangle, right, this will be what is going through my mind. First, are they similar? If they are not, do they have common height? If they don't have, then do they have common base? If they still don't have, then some other method. Okay? So let's go back to questions. Okay, this one, try 11. With our remaining 10 minutes, let us do this. Try it 11. I want to draw my small triangle. Okay, I hope you have this triangle over here. AEB similar to CED. CE is 6. Then I've got vertically opposite angles. I've got alternate angles. Since 3 pairs of corresponding angles are equal, triangle EAB similar to triangle ECD. Okay, so since they are similar, this being 13.5 square centimeters will allow me to find the area of the bigger triangle easily. So part A, area ABE over area ABE is my big triangle, so over the small triangle CDE will be equal to
6 over
10 over 6, right? Bigger over smaller. So this is actually 5 over 3. No, we need to square it, yeah. 5 over 3 square to get 25 over 9. So now substituting the values, CDE, we've got an area as 13.5, so area ABE equals to 25 over 9 times 13.5. 5 divided by 9, we get 37.5. Okay, so that's a right angle triangle. Don't have. So this is my base. If this is my base, my height will be from B, drop a perpendicular line down, right? Is EB perpendicular to EC? Yes, no, or maybe?
Maybe.
Maybe, I don't know. So I'm going to draw another line down to pretend that, yeah, okay, this is my 90 degree. Make sense to you? So the base is now EC, which is 6 units, 6 cm actually. Then the height will be from B, drop down over here. Can you find another triangle that has the same height? Should be quite clear lah. What is a triangle that has the same height? And the base is also known. Which one? Think, look carefully. This is my height, huh? Height. Which other triangle shares the same height and the base is also known? A, E, B. Okay, I'll draw the triangle for you. It is over here. A, E, B. Doesn't this blue triangle share the same height if the base is 10?
Yeah.
Right? Okay, so this is what I'm going to be using. For part B,
So what will be ABC?
A, B, C. Yeah, you can also, but it makes things a little more complicated.
Then how you know which one to choose?
Because I already have the area for the blue triangle. I found it in part A,
Oh.
right? So these are all related. So part B, area of BCE. I put my unknown in the top left. It's going to be ratio again. Area of the yellow triangle divided by area of AEC equals to, do you want to write down half times base times height? Or straight away write down the ratio of base?
Ratio of base.
Yeah, we can do that. We can do that. So BEC, the base will be 6 divided by 10. Okay? Then area of AEC, no, sorry, it's not AEC, it is AEB. I wrote wrongly. Divided by area of AEB is 6 over 10. So now my answer is simply BCE is 6 over 10 times 37.5 to get the answer, which is 22.5 square centimeters. Can?
Yes.